In a previous discussion, I introduced the vector, raster, and triangulated logical geospatial data models. Now I want to explore each of them more closely. The vector model allows us to model discrete features with precise shapes and boundaries. So model geographic objects, for example, as points, lines, and polygons. The features themselves are discrete. They exist where we model them and they don't exist somewhere else. For example, a lake is represented as a polygon. And if I was standing in the lake, I would be wet. The lake exists. But if I'm standing on the shore or somewhere else, there is no lake and the lake does not exist. That is a discrete object and it has a precise shape and position. That is the shape and location of the lake itself. We locate vector objects on a Cartesian coordinate system. And so if you look in the example below, you can see points, lines, and polygons that are located on a Cartesian coordinate system in which the origin in the lower left-hand corner is 0, 0. And so, for example, points can represent things like cities or fire hydrants. Lines can represent a grid line or a flight path, and polygons can represent things like oceans or zip codes. Vector objects are located in geographic space by transforming the Cartesian coordinate system to a geographic coordinate system. So the points are converted from a pair of Cartesian xy coordinates to a pair of geographic xy coordinates. The lines are just a set of coordinates that define a shape. So in the example below, we can see that the line is made up of 3 points that are connected by 2 lines. Polygons are just a set of coordinates defining boundaries that enclose an area. And so again, in the example below, you can see that all a polygon is a series of points in which the first point and the last point are coincident or the same. The vector model allows for attributes in which non-spatial information is stored about the geographic features. Feature attributes are arranged in tabular columns. So it's basically the tabular data model, the difference being that each vector feature is linked to a tabular row with descriptive values. So in the example below, you can see there's a map that includes address locations 102 and 101. The point feature 102 is highlighted, and the corresponding record in the table is highlighted as well. So that particular address location, 102, is at 901 Main Street, is owned by Jane Doe and is a commercial establishment. Now, there are advantages and disadvantages to the vector model. The advantages are they're really great at representing discrete features like rivers and states. The points are placed precisely where you need them, and so they can be very accurate. The vector model also supports advanced modeling such as networks and topology. So when we use Google Maps to route a location from A to B, we're utilizing advanced modeling like a network to do that. The disadvantages of the vector model include the location of each vertex must be stored explicitly, which can require a lot of computer resources to manipulate and analyze vector data. Also, vector data cannot easily represent continuous but varied geographic phenomena. There are a number of vector file formats that we can utilize in ArcGIS. The geodatabase feature class and ESRI shapefile are the most common because we can create, delete, read, and write these vector formats. Also, we're seeing a lot of LiDAR data now, which is basically a bunch of points represented by an XYZ. And in ArcGIS Pro, you can delete, read, and write a .las file, which is a LiDAR file. Other vector formats that we utilize in ArcGIS include ESRI coverage, which I mentioned previously, is a dated vector format that we typically just read in and then convert it to something else. You can also read in computer-aided drafting files like an AutoCAD drawing file or a MicroStation design file. You can read in Google files. You can also import in MapInfo files, and you can read and copy ArcGIS Online vector layers. So typically, if we're just trying to explore data, we might just read it in or import it. But if we actually want to start analyzing and working with data, then we'll typically use an ETL process to convert it from its source format to a target format like an ESRI shapefile or a geodatabase feature class.